What's going on, guys? In this video we are going to see how to find out unknown branch currents and mesh currents using mesh analysis by inspection method. Now in order to do this method we have to follow all these 4 steps. The first step is assign mesh currents. So assign mesh currents mean we assign mesh currents to each loop. So this is going to be I1 and this is going to be I2, right? Now we have mesh currents. The next step is find resistance matrix elements. So resistance matrix is going to be addition of all the resistance in a mesh. So in the first mesh we have 5 ohm, 10 ohm, and that's it. So we are going to add them together. So R11 is going to be 5 plus 15, and that's equal to 20. Actually 15 plus 10, 5 plus 10, right? I made a mistake right here. It should be 5 ohm plus 10, and that's gonna be 15. And R22, all the resistance in the second mesh. We have 10 ohm, 6 ohm, 4 ohm. So this is going to be 10 plus 6 plus 4, and if you add them together that's going to be 20, right? So this is 20 and this is 15. After that we have to find the resistance in between two, that is shared by 2. So here the resistance that is shared by these two meshes is going to be 10 ohm. So R12 is going to be 10 ohm, also R12 and R21. But here we have to put one more thing, that is we have to put a negative sign, right? After these 3 things we have to create a matrix. In the matrix, this is going to be the location: first column, first row, first column, second row, second column, and this resistance that was shared by these two, that's going to be in the first row second column and second row first column. Now this is going to be just diagonal, right? First row first column 15, and for second row second column 20. So this is the diagonal, and no matter how many meshes you get, always this is going to go like this in this side diagonal. Now this is going to be in the first row second column, so this is going to be negative 10 right here, and also negative 10 in the second row first column, like this, right? Now we are trying to find first mesh and the second mesh, and then after the equal sign we have to put the voltages. So voltages is basically we have to look at the current's direction and see the voltage, whether it is voltage rise or voltage drop. And if it goes from minus to plus, that's going to be a voltage rise. So in the first one we have this I1 going through this minus to plus, so this is voltage rise right here, and also this I1 going through this 10 volt, that is plus to minus, in this direction that is plus to minus, so that's going to be voltage drop. So this is going to be minus 10, and then I2 is going from minus to plus, and only one voltage source is right there, so this is the only one we are going to put right here, and it's going to from minus to plus, that's going to be a voltage rise, so this is going to be 10 plus 10, right? Now we have this one also, instead of 15 minus 10 we can just write 5. And after we created this matrix, all we have to do is Cramer's rules. So Cramer's rule is basically we find the determinant of this original matrix. So to find the determinant for a 2 by 2 matrix we use AD minus BC. If it's ABCD, determinant is going to be just AD minus BC, right? So here we are going to arrange them like 15 minus 10 minus 10 20, and here if you cross multiply 300 minus 100, actually plus 100, that's going to be again minus 300 minus plus 100, so that's going to be 200, right? So this is going to be just 200. Let's put 300 minus 100, 200. And now what we have to do is to find I1 we have to swap this voltage with the first column. So if we swap with the first column, that's going to be 5, 10, and the second column remains the same, that is minus 10, 20. And now we have to do the AD determinant. We have to find the determinant. Again, it's AD minus BC. 20 times 500 minus 100 minus 100, so that's going to be plus 100, right? So this is going to be 100 plus 100, so that's going to be 200. And again, to find the second current, we have to swap this one with the second column. First column remains the same, that's going to be 15 minus 10, and the second column changes into 510. Again, we have to find the determinant of this one. That's going to be 15 times 10, 150, minus 50, that's going to be plus 50, again that's going to be 200. So this is also 200. Now to find the current, we are going to use Cramer's rule. Cramer's rule is basically whatever the swapped with one, if you want to find I1, you swapped this one with the first column and found the determinant. So that's the one going to be on top, 1 over the original matrix determinant. Now 1 is 200 and the original determinant also 200, so this is going to be just 1 ampere. And to find I2, same approach. Whatever the determinant we get from swapping with the second column, that's 200. So this is going to be 2 over D. So this is going to be 200 over the original determinant, that is 200. So this is also 1 ampere. So we have these two, we found out these two mesh currents. The first mesh is 1 ampere, also the second mesh is 1 ampere. Now if you want to find the branch current, so let's say this is I1. I1 is going to have the same current as big I1 because this is the only current going through this one, right? So this is, both are going to be same. Also, if you put I2 right here, this I2 and this I2 is going to be same. Now let's say we have a current in the middle. So let's say you have something like this, you put I3 right like this. Now if you want to find this one, we have to look at the direction. So I2 is going along with this I3, so that's going to be positive I2, and I1 is going opposite of this one, so that's going to be minus I1. And we found out I2 and I1, both of them are 1 ampere, so this is going to be 1 minus 1, and that's going to be 0. So we are going to have 0 current. We are not going to have current right here. So that's how we find out currents using mesh analysis by inspection method. I hope you guys find this video helpful. See you next time.